Hello, how are you? My name is Tapwanyemba and I'm here to help you with the Pythagoras Theorem. So we have a question we need to work through together. And the question reads, a triangle has sides 3 centimeters, 11 centimeters and 15 centimeters. Determine if it is a right triangle. So the moment we are asked to determine if it is a right triangle, there we need to know that we have to apply the Pythagoras theorem. So firstly we have to write Pythagoras theorem. And the Pythagoras theorem, we know that a squared is equal to b squared plus c squared. So a squared is equals to b squared plus c squared. Then we need to determine what the hypotenuse is. And because of the structure of our Pythagoras theorem, which is a squared is equals to b squared plus c squared, automatically our hypotenuse is represented with the letter a, and it is equal to, now we have learned that the hypotenuse on a right triangle is actually the longest side of the three. So our sides are 8 centimeters, 11 centimeters and 15 centimeters. So the longest of the three is actually 15. So our hypotenuse is 15 centimeters. Then we have to determine the side B, which we can take to be 8 centimeters, and the side C, which we can also take to be 11 centimeters. So knowing so, we now need to apply the Pythagoras theorem. So the Pythagoras theorem here, we are substituting for a squared with 15. So 15 squared is equal to 8 squared plus 11 squared. And what is 15 squared? So I am not that much of a geek or a genius in mathematics, so I actually worked through on a separate paper. But if you are being examined in a paper which actually allows you to use a calculator, you can just punch in 15 squared. So 15 squared, I have to go on a rough paper, knowing that 15 squared is just 15 times 15. So here we have to put our placeholder. 1 times 5 is 5, 1 times 1 it's 1. Then 5 times 5 is 25, we put the 5 here and the 2 here. 5 times 1 is 5 plus 2 is 7. 0 plus 5 is 5. Then 5 plus 7, that must be 12. With a 1 here, 1 plus 1 is 2. So here at 15 squared we are getting 225. Is it? Yes, it is. So it's 225 is equal to 8 squared, that's 8 times 8 is 64, plus back to my rough paper, 11 squared is 11 times 11. Here it's 0, 1 times 1 it's 1, 1 times 1 it's 1, 1 times 1 it's 1, 1 times 1 is also 1. We add the 2, 0 plus 1 it's 1, 1 plus 1 it's 2, and 1, 1. So here it's 121. Now we need to know what 64 plus 121 is. So we are saying 121 plus 64. 1 plus 4 is 4. 1 plus 2, I'm sorry, it's 2 plus 6 rather, it's 8. And then 1, so 184. So here we are getting to 225 is equals to 180. So here it's 1 plus 4, it's 5. 2 plus 6, it's 8. I'm sorry, I was just absent-minded. So 185. But 225 and 185 are not equal. So to make these statements correct, this is the sign for not equal to. And then we conclude. Therefore, since a squared is not equal to b squared plus c squared, comma, triangle is not a right triangle. Right triangle. This will be the solution. So we have to go through our second example number 2, and then I will leave you with a question you have to attempt on your own. So thank you so much. I hope you posed the question, considered how I went through it, and did it on your own, because you just don't have to observe, you have to be an active learner for you to master the concepts. So we are now on example number 2, and it reads, the sides of a triangle are 8 centimeters, 17 centimeters, and 15 centimeters. Find if it is a right triangle. So firstly, the moment we are tasked to find if it is a right triangle, we know we have to apply the Pythagoras Theorem. The Pythagoras Theorem. And the Pythagoras Theorem is a squared being equal to b squared plus c squared. Now we have to determine what is our hypotenuse. And because of the structuring of the Pythagoras Theorem, our hypotenuse is a, because the hypotenuse squared should give us either side squared as a sum. And the hypotenuse being a is, we learned also, and I reiterate, that the hypotenuse is the longest side of a right triangle. So the sides we are given are 8 centimeters, 17 centimeters, and 15 centimeters. The longest of them being 17. And then we determine the sides. We have side B, which we can take to be 8. And we also have side C, which we are taking as 15. Now, applying the Pythagoras theorem, a 17 a squared, so we are having 17 squared being equal to, and our b is 8, so it's 8 squared, plus our c is 15, so 15 squared. Having this, we are now going to work through. If you are using a calculator, if you are allowed to use a calculator by your examining board, you can use your calculator, but I love being handy, so I'm just going to work through 17 times 17, that's 17 squared. So our placeholder, 1 times 7 is 7, 1 times 1 is 1. 7 times 7 is 49, our 4 here. 7 times 1 is 7 plus 4, 8, 9, 10, 11. So I was taught by a certain teacher whose name was Mr. Charumbira, and is the one who told me that it is not embarrassing to count your fingers. That's why you saw me counting my fingers. So 0 plus 9 is 9, 7 plus 1 it's 8, and 1 plus 1 it's 2. So here for 17 squared we have 289 being equal to 8 squared 64 plus 15 squared. If we go back to our previous question, we learned that actually 15 squared is 225. Now we have to add 64 and 225. So 225 plus 64, 5 plus 4 it's 9, and 2 plus 6 it's 8, then 2 is 2. So we are having 289 equating 289. So we have to conclude, and therefore since a squared is equal to b squared plus c squared, comma, triangle is a right triangle. It's a right triangle. So in a moment I'm going to write down the question. I am tasking you to work on your own, and you are free to send over your solution. But basically this is how we use the Pythagoras theorem to determine if a triangle is right angled or not, provided we are given all the three sides. So as a form of catching up, a recap, we learned the basic applications of the Pythagoras theorem. That firstly, we use the Pythagoras theorem to determine the sides or the missing side on a right triangle. So we are given two sides and we determine the missing side. The missing side might be the hypotenuse, or it might be any side. Then the second basic application of the theorem is determine if a triangle is a right triangle or is not. So I've just taught you the second basest application of the Pythagoras theorem. But I'm going to come through with more complicated or challenging questions, which I'm going to work with you through. But some of the questions I'm just going to give you to challenge your mind so that you work on your own. And if you find them challenging, you just attempt and send over your solution, and then I will see if your solutions are true or they are not. So after I have given you the homework, take homework, assessment, assignment, whatever term you find comfortable to use, then our lesson for today will be done. Thank you. Okay, we are back to conclude this part of the lesson. That is the take homework or homework. So the question reads, given that the sides of a triangle are 20 centimeters, 21 centimeters, and 29 centimeters, find out if the triangle is a right triangle. So the frame of what you have to follow to be able to answer this question properly is knowing that you have to apply the Pythagoras theorem. You determine what your hypotenuse is, and then you find the left and right hand sides to see if they equate, then you conclude your solution. I see it best if you do not copy or just follow through what has been written on top there, but to take the question separately and then you also answer separately. Thank you, and it's bye for now.